You are welcome to this lesson. In this lesson, we are looking at trigonometry. Trigonometry is a mathematical concept that studies the relationship between sides and angles of triangles. We are particularly going to look at right angle triangles, but we will also look at non-right angle triangles, and that will lead us to looking at the sine and the cosine rules. And all these we are going to study in relation to the unit circle. And by unit circle, I mean a circle with radius 1 unit. We are going to look at two ways of measuring angles, or two units of angle measure: degree measure and radian measure. So we start by looking at the degree measure. Let's take the first diagram. Now, in measuring angles in trigonometry, our reference points, or we start measurement from the positive x-axis and then we move anti-clockwise. If that happens, we obtain a positive angle. On the other hand, if we measure in clockwise direction, the angle we obtain is a negative angle. But what is more important is for us to note that our measurements start from the positive x-axis, and the direction may be clockwise or anti-clockwise, but preferably anti-clockwise, as in the first diagram here. Now we want to relate positive and negative angles. As you can see from my arrows, the red background, the red arrow here gives us the positive angle, and then the blue one gives us the negative angle. That's because the red one is in anti-clockwise direction and the blue one is in the clockwise direction. Now looking at this diagram, you see that from the positive x-axis here, the positive angle reaches this line, and then the negative angle also reaches this same line. What that means is that if it is a coordinate that is here, that will give us the value that we want. Then it means the blue one will give us the same value as the red one. Okay, so in effect, we are saying that when we have a positive angle, it has a related angle that is negative, where the two will have the same value. For instance, if I have the angle, let's say 150 degrees, and then I have another angle 210 degrees, which is negative, then it means that from here to here is 210 negative, and then from here to here is 150 positive. You get it? Okay, so let's check if they are going to give us the same values. So we are going to check with sine. So sine 150 degrees, is it the same as sine of negative 210 degrees? So check with your calculator. So in each case, I got 1 over 2, 1 over 2. So that's what I had. I believe you also had the same set. Okay. So this conclusion has been drawn here that if I have sine theta, this sine theta is equal to, so when I take a whole 360 degrees, I'll just subtract the theta from it, the remaining. So when you take a complete revolution and you take the red portion out, the remaining, when you negate it, it goes for the other side. and so I negate the remaining when I subtract theta from the sine. And the same thing with the cos and the tan as well. So you can check to verify for all of them. Now, as we said earlier, on the s-axis, because it is exactly on the reference point, the angle is 0 degrees. And so as we move in anti-clockwise direction, the angle will be increasing. When we get to the y-axis, positive y-axis, we get 90 degrees. We keep on moving. When we get to the negative s-axis, we get 180 degrees. Remember, angles on a straight line is 180 degrees. And then we keep on. So when you get to negative y-axis, we get 270 degrees, noting that our reference is the positive x-axis. So when we make a complete revolution, we get an angle of 360 degrees. So that is how angles are measured in degrees. Circles have very interesting features. One of them is that for every circle, when you take the circumference and divide by the diameter, it gives a value that is true and equal for all circles. And because of that, it has become a constant, and that value is pi. Now, diameter is 2 times the radius, and so this expression can be written as c over 2r is equal to pi, where 2r means the diameter. Now, if I decide to make c the subject, I'll multiply through by the LCM, which will give me c is equal to 2 pi r. And that is what we get in a complete revolution or in a circle. Now let's come to the radian measure of angles. An angle described as radian is the angle that is subtended by an arc which is of equal length as the radius of the circle. Now I have this arc here, which is indicated with a blue color, and according to the diagram, the length of this arc is r. Now the length of our radius is also r, which means the length of the arc is equal to the length of the radius. In such a situation, this arc subtends an angle here. And that angle, the size of the angle is described as radian. So it is 1 radian. So when we say a radian angle, we are talking about an angle that is subtended by an arc which is of equal length as the radius of the circle. Alright, so with this said, let's look at the total number of radian angles we can find in a complete revolution. For a complete revolution, we have c, that is the circumference. And so when we divide by an arc length which is equal to the radius, we get to the total number of radian angles in a complete revolution. Let's note that c is the same as 2 pi r. And so when I divide this by r, I'm going to get r to cancel out, and the result will be 2 pi. So for a complete revolution, the total number of radian angles is 2 pi. So radian angles of a complete revolution is 2 pi. And then for degree measure, the total number of degrees in a complete revolution is 360 degrees. So let's take note of this. We have established that for a complete revolution, the total number of angles in a degree measure will be 360 degrees. And the total number of angles in a radian measure will be 2 pi. That means the two are equivalent. Okay. Now, I'll take you back to GHS where we did pie charts. And in pie charts, we were able to find the percentage value of a sector when its degree value is given. So assuming the sector has a degree of 36 degrees, and then we need to find the percentage of it. What happens is that we find the fractional equivalence of 36 degrees, which becomes 36 degrees over 360 degrees. So that will be the fractional equivalence. Now, remember, it is degree over degree, so the degrees will cancel out. Then when I simplify this, I'm going to get 1 over 10 as the fractional value of 36 degrees. Now, I multiply this fractional value by 100, which gives me the percentage value. So 1 over 10 times 100, and that will give me 10%. So 36 degrees is equivalent to 10%. This is how we did our calculation. We are bringing the same idea into converting from degree measure to radian measure. Okay, so if you are to convert, let's say, a value in degrees, and let's take pi to be the value in degrees that we want to convert. So we need to find a fractional equivalence, which will be pi over 360 degrees. And that we will multiply this by 2 pi, which when the degrees cancel out, now our new value or unit will become the radian. 2 pi is in radian, so it becomes radian. So if I want to simplify this expression, I'll write 2 pi theta over 360 degrees. Then you realize that 360 and 2 can be simplified. So 2 here, and this one becomes 180. So this can be simplified as theta over 180 times pi. So for you to convert from degree to radian, this is how it should be. The angle you want to convert divided by 180 degrees times pi. Or if you want to take the original, the angle you want to convert divided by 360 times 2 pi. And this is how we convert from degree to radian. Now, to convert from radian to degree, what you have to do is to also find the fractional equivalence of the value which is in radian. Okay, so assuming you have alpha, which is in rad, and then you want to convert it to degrees. So alpha, remember the total number of angles in a complete revolution in radian is 2 pi. So you divide what you have by 2 pi. That gives you the fractional value of it. And then the result will be multiplied by 360 degrees. This one also, if you simplify, you see that 2 will cancel 360 into 180. So the value in rad over pi is multiplying 180 degrees. And this is how we do the conversion from radian to degree. I hope this is understandable. We have seen angle measure in degrees, and we have also seen angle measure in radian. Now, for a complete revolution, we start from here, 0, which is on the positive x-axis. Then we go round and come back to 0. But once we go round and come back, we have made a complete revolution, which should be 2 pi. Then for the degree measure, we start from 0, we go round and come back. Once we have made a complete revolution, you have 360 degrees. Now when I have 360, I get 180, which is what you see. When I have 2 pi, I get pi. So that's it. Half of 360, half of 2 pi. Now, if I have pi, what will I get? I'll get half pi. If I have 180, what will I get? I'll get 90 degrees. So let me do the conversion to see whether they are actually true. So 90 degrees divided by 180 degrees times pi. So 90 goes here, 1 goes into 180 twice, and that gives me 1 over 2 pi, which is true. That's 90 degrees is equivalent to half pi. Okay, now when I have 90, I get 45. And when I have 1 over 2 pi, I get 1 over 4 pi. So let's also do the conversion to also verify once again. So 45 over 180 times pi. What will that give? 45 goes into itself once, go into 180 4 times. And then that will give me 1 over 4 pi, which also is true for what I have here. And so this is how we verify the conversion.